most of numericals are coming in the EMF equation of an alternator, distribution binding and short pitch bindings. Distribution binding and coil span binding, or you can say cording bindings. So first I have already explained how we'll derive the EMF equations. But again I repeat, because these two topics are very, very important for solving the numericals. So first we take the EMF equation, and in EMF equations, first we share the screen and then we'll come on the EMF equation of an alternator. Let Z is equal to number of conductor or coil side in series per phase, and phi is flux per pole in Weber, P is number of rotor poles, N is the rotor speed in RPM. In one revolution, since speed of the conductor in RPM, N RPM, so you can convert this in one revolution, that is 60 by N seconds. Each stator conductor is cut by P5 Webers. In one cycle, it will cut the flux produced by all the poles. So that will be the flux cut by the conductor is P5 Weber. That is d phi is equal to P phi, and dt is equal to 60 by N second. So average EMF induced in one stator conductor, rate of change of flux, that is equal to d phi by dt. And if you write d phi, already you have derived d phi is equal to P phi, and dt is equal to 60 by N. You put these value in this expression and you find that is P phi upon 60 by N, and that will be equal to the P phi N by 60 volts. This is voltage induced in one conductors per phase. Now for deriving of these equation, we are doing two main assumptions. First, binding is concentrated binding, and that is full pitch binding. These two assumptions are taken in consideration for deriving these equations. So average EMF, now I have already derived the speed N, synchronous speed N is equal to 120 F by P. This expression has already been derived earlier in the class. So if you put this value in the place of n. You will find P phi n by 60 into 120 by F by P. So you will find average EMF per phase 2 F phi by Z volts. If you take in the place of conductor, if you take a turn of coil, a turn of coil having two sides, one side is voltage induced, in second coil will also voltage induced. The direction of voltage induced in both the coils are same, hence total voltage induced is double of the voltage induced in a single conductor. So this expression will be multiplied by 2. This will be multiplied by 2. इसलिए average EMF per phase is equal to 2 F phi into 2 TP. When you are using in the place of conductor TP, the voltage induced, average voltage induced in a turns of coil is double, that is 4 F phi TP volts. These values are average EMF induced, but we are considering that is RMS voltage induced, RMS value of EMF induced per phase equal to the average value of EMF induced per phase multiplied by form factor, that is 1.11. So total voltage induced, RMS value of voltage induced per phase will be EP is equal to 4.44 F phi TP. So this is the equation of voltage. This is expression of voltage induced in per phase conductors. So in this way, if you see this expression, I have already told you this expression is derived by assuming that, hello, good afternoon. नहीं क्लास ले रहे हैं.
अरे सर कैमरा ऑन है.
Now we come on the, this is the EMF induced per phase of a synchronous generator. This expression is very useful in the case of solving the problems. Since this expression is derived by assuming that coil have full pitch coil and all the conductors are concentrated in one side. Now second, we come on the winding factor. If you come on the winding factor, we can come binding factor. I have already told you there is a two binding when we are using in synchronous generator short pitch binding and distributed binding. So when we are using short pitch binding, the voltage induced in the short pitch binding is less than the voltage induced in the full pitch binding. Similarly, when we are using distributed binding, the voltage induced in the distributed binding is less than voltage induced in the concentrated binding. So in this way, for getting actual voltage induced, when you are using short pitch coil and distributed binding, voltage induced you will get, if you calculate the induced voltage with this formula, you will get more voltage induced. For finding out the actual voltage induced, we are using these two factors. First factor is pitch factor or coil span factor are also known as a carding factor. Second is the distribution factor, KD, also called breadth factor. Now we come, what is the pitch factor? Pitch factor, when you are using the full pitch coil, voltage induced in all the conductors is in the same direction, and total voltage induced will be arithmetical sum of voltage induced in all the conductor. If suppose there is a conductor EA and we take two conductor, that is EA and EB, if you take a turn of coil, you see here, this is a turn of coil that is having two sides A and B. And this is dotted portion will showing the full pitch coil, and this coil is less short angle is alpha. So total span of this coil is 180 degree minus alpha of the short pitch binding. In this case, voltage induced in conductor A and conductor B are equal in magnitude. But in the case of distributed binding, voltage induced is, suppose in conductor coil A is EA and in coil B is EB. In amplitude, the voltage induced in both the coil will be equal. So when the binding is, that is concentrated binding, the voltage will induce in both will be the arithmetical sum. It means resultant voltage induced ER is equal to 2 EA. So if you take the distribution binding, happens. If you take the short pitch binding, the voltage induced in coil A is equal to the voltage induced in coil B. But there is a phase difference. Resultant will be obtained. There will be phase difference between two. That is, voltage induced in coil A is AB, that is EA, and voltage induced in the coil is EB, and the phase difference between two is alpha. So resultant AC you will obtain with the phasor sum of EA plus EB. If you take, how will calculate this factor? For calculating of this factor, now pitch factor Kc is equal to EMF in short pitch coil upon EMF in full pitch coil. So AC upon 2AB, that is AC, if you see the previous figure, if you see in this figure, that is take angle triangle ABD, then what is the value of AD? AC is equal to 2AD. You can calculate the value of AD is equal to, that is equal to ER is equal to 2EA cos alpha by 2. If you put this value in the expression, this AC upon 2AB, that is 2EA cos alpha by 2 upon 2EA cos alpha by 2. For full pitch binding, this is the formula. Kc is equal to cos alpha by 2, where L is L, that is alpha is the angle by which the coil is short pitches. For full pitch binding, Kc is always equal to 1, and for short pitch binding, Kc is less than 1. Now we come on the distribution factor. The factor, distribution factor, the factor by which there is a reduction in the induced EMF due to distribution coil is called distribution factor, as it is denoted by Kd, or we can say that is Kd is equal to EMF with distributed winding and EMF with concentrated winding, EMF with distributed winding and EMF with concentrated winding. Now how we'll calculate phasor sum of coil EMF per phase and arithmetical sum of coil EMF per phase. Now if you, for this, there is two things, that is M, slots per pole per phase. This is the, and M is equal to slots upon pole oblique phase. Second is the beta, the angular displacement between adjacent slots in electrical degree. Since total charge per pole is total distance, angular distance between adjacent pole is 180 degree, and total number of slots per pole, if you divide by this, you will find the value of beta. So beta is equal to 180 degree electrical upon number of slots upon pole per phase. So this is the, these two things are required for deriving the equation. Now suppose total number of conductor is M. We take M as a 3 slots per pole per phase. So what will be the, if the binding is concentrated binding, all the conductors per phase per pole are lying in the same slots. So the voltage induced in all the conductors are added arithmetically, and in this case if you take, suppose this is the M conductors, we are taking value of M is equal to 3. It means this is AB, BC and CD, and this may be more than this, but this is shown, and resultant of these two, AB, BC, resultant of these two are, that is phasor sum of AB, BC and CD, and the angle, the angular difference between all phase will be beta, that is angular difference, angle between the two slots per phase. So this is the beta. So now how we'll calculate the value of Kd, and the resultant EMF induced is, this is AD. If you, these are the chord of the circle AB, BC and CD. If you draw a circle taking center as O, all A, B, C, D, all points will lie on the periphery of the circle. And if you draw a vertical line from O to U, connect AO, all the chord AD, AC, AB, and a vertical line drawn from O on AD, that is cut by X, and it is by secting AD. Second AB, it's intersect at Y. So if there is a M slots, the total angle between all slots is M beta, and the half of the slots, that is AOX, will be M beta by 2, and this is the, this is one slots and this is one slot. The angle between two slots is beta. So, and this is bisector of AB, and the angle AOY is beta by 2. From this you can calculate, that is AD is equal to AD, the phasor sum of coil EMF AD. KD is equal to, what will be the KD? Voltage induced in the coil when it is full pitch coil, and voltage induced in the coil when it is the short pitch coil. So in this way, voltage induced will be
सर सिस्टम पे कुछ आ रहा है।
शेयरिंग खत्म हो गई है। That is AD M into AB, that is AD is equal to 2AX. If you see the figure, AD is equal to 2AX and AB is equal to 2AY, and you will find AX by MAY. If you go in the figure, you will find in this figure, what will the value of AX? You take triangle, this triangle AOX. What is the value of AX? AX is equal to AB sine M beta by 2. And what will be the AY? AY is the equal to AO sine beta by 2. So you can write in the above expression, that is OA into sine M beta by 2 and M OA sine beta by 2. OA will be cut together and we find the value of KD sine M beta by 2 upon M sine beta by 2. In this way, you calculate the value of KD. The value of KD, MB is the phase spread. Distribution factor KD for a given number of phases is dependent only on the number of distributor slots under the given pole. EMF equation. Now, EMF equation you have already derived previously, that is 4.44 F5 TP. This EMF equation is based on the assumptions that binding is the full pitch binding and concentrated binding. Now, for finding the actual voltage induced in the case of synchronous generator, when you are using binding, that is short pitch binding and distributed binding, you multiplied by these two factors Kc and Kd, and you will find the actual voltage induced. So this is the expression. These two expressions, these are the very important in calculation of the solving the problems. Now we come on the problems. If you Now time is almost completed. We take the attendance. Okay. Now we'll take the attendance. सबको unmute कर सकते हैं। हेलो, अनम्यूट हो गए सभी लोग, अनम्यूट हो लीजिए।
यस सर।
अनम्यूट हो लीजिए सभी लोग। अटेंडेंस
बोले
सभी लोग अनम्यूट हो लीजिए। हेलो,
नहीं यार पहले चाहिए
सभी लोग अनम्यूट हो लीजिए।
कोई नहीं यार अनम्यूट
हो लिया सर।
Now we'll take the attendance because time is too short. Only 40 minutes is.
यस सर, टाइम इज टू शॉर्ट, अटेंडेंस ले लीजिए।
अगर जो है ये बंद हो जाता तो फिर जो लोग अटेंडेंस नहीं ज्वाइन कर लेंगे on same ID password. That privilege is available in this. So there is no problem.
अरे हो जाएगा सर, 20 ही लोग तो हैं, 20-25 लोग।
सर फटाफट ले लीजिए अटेंडेंस।
अंकित पांडे, हेलो अंकित।
प्रेजेंट सर। अर्पित प्रेजेंट है।
अंकित
अनुभव
है अंकित भी।
1002
हेलो।
अनुभव
हाँ सही आ रही है।
अनुभव आवाज नहीं मिल रही है।
मिल रही है सर।
अनुभव
बोलो भैया।
बोलते जाइए ना। अनुभव
यस सर।
709 रोल नंबर 54.
अर्पित
यस सर।
दर्शिका दिव्यांग
यस सर, यस सर।
गार्गी
प्रेजेंट सर।
क्षितिज
प्रेजेंट सर।
मान्य
मन्या
प्रेजेंट सर।
मुरली मनोहर
शेषाद्री
सादरी
प्रेजेंट सर।
शिवम श्रीकांत
यस सर।
वासुदेव
प्रेजेंट सर।
विशाल
प्रेजेंट सर।
अब्दुल
यस सर।
अफसार
प्रेजेंट सर। प्रेजेंट सर।
आनंद प्रकाश
यस सर।
अनीश कुमार
यस सर।
ब्रिजकिशोर
प्रेजेंट सर।
मनी,
यस सर।
मयंक,
यस सर।
नितिन, नितिन, पिंटू, पिंटू सानी, रमेश, रमेश,
Yes, sir. Yes, sir. Prathamesh is present.
संदीप, संदीप, संतोष, कुमार,
यस सर। यस सर संतोष।
शुभम पांडे,
यस सर प्रेजेंट।
श्वेता,
Present, sir.
बंदित,
Yes, sir.
विवेक,
यस सर।
आकांक्षा, आकांक्षा, आकांक्षा नहीं हो गए, बाद में कर। 1 2 3 लोग बचे हैं। अंकित, अंकित का जो है नहीं बोले थे, नहीं होंगे। अनुभव, मुरली मनोहर, शिवम, अनीश कुमार यादव, नितिन जायसवाल, पिंटू सानी, संदीप कुमार रस्तोगी, आकांक्षा।
सर मेरा नहीं लगा सर।
बोल तो रहा हूँ, बोल क्यों नहीं? क्या नाम है तुम्हारा?
सर 109 यशस्विनी श्रीवास्तव।
अश्वनी।
यस सर 54 में 109 यशस्विनी श्रीवास्तव।
इसमें नहीं। ठीक है, तुम तो बहुत पहले से कनेक्ट हो गई हो।
तो सर आपने नाम नहीं लिया था।
तुम्हारा नाम ही नहीं इसमें जो है, तो मैं क्या नाम लूं? चलो ठीक, हो गया। ठीक।
सर मेरा 54 में ही नाम है।
हाँ बेटा, लेकिन इस जो मैं लिस्ट मेरे पास है इस समय, ये अभी फाइनल लिस्ट नहीं है ना, इसमें तुम्हारा नाम नहीं है। अश्वनी श्रीवास्तव तुम्हारा उसमें मैंने लिया।
लिख लीजिए सर कहाँ।
उस दिन भी प्रेजेंट थी, इसमें भी प्रेजेंट।
तो किस दिन?
पिछले दिन 18/8 को। चलो ठीक।
सर हम लेक्चर्स में प्रेजेंट थे, ट्यूट में 54 में ही प्रेजेंट हैं।
ट्यूट में भी तुम्हारी अटेंडेंस है, पिछले ट्यूट में 53 में। चलो नो प्रॉब्लम। हाँ चलो, कोई दिक्कत नहीं उससे। तो सभी लोग जो है
लीव करें,
मतलब 40 मिनट का पूरा सेशन होता है, तो 40 मिनट आप लोग आराम से जो है शांत पूर्वक रहिए। 10 मिनट 30 मिनट पढ़ाएंगे, 10 मिनट अटेंडेंस में। अगर इन केस मिड ऑफ द अटेंडेंस में ऑफ हो जाता है, फिर रिकनेक्ट हो जाएगा। देयर इज नो प्रॉब्लम। अगला हमने न्यूमेरिकल भी सोच रहे थे, कुछ चीजें जो है न्यूमेरिकल्स करो, लेकिन आज जल्दी हो गया है, तो नाउ विल
अब अगली बार
इन नेक्स्ट टर्म्स
लीव करें।
टेक द न्यूमेरिकल्स।
हेलो सर।
हाँ
सर संदीप कुमार रस्तोगी सर, नेटवर्क वजह से रिकनेक्ट हो गया था, इस वजह से बोल नहीं पाया। हम ज्वाइन थे सर।
अच्छा अच्छा, चलिए अभी है टाइम।
संदीप कुमार रस्तोगी 9013।
हमने रिपीट भी किया है।
वाह क्या बात है, सो जाते हो यार तुम लोग।
अब सर
क्या क्या